So now I want to invite Dr. Chemchem from the company ATOS. Amine Chemchem is a well-known person from France. He worked here at the university for about 3 years, and then unfortunately he was picked by the company, so now it is in the dark side of the force. But anyway, you have the mic. This one. Thank you.
Hello, everyone. So thanks, Luis, for the introduction. My name is Amine Chemchem. I'm a data scientist today in ATOS Montpellier. And today I will present you some of my feedbacks in the domain of artificial intelligence applied on smart agriculture. So I will start my presentation by a small introduction of ATOS, and then I will present to you two projects of smart agriculture I choose. The first one is called Terra Occitania, and the second one is DIVA project, and I will conclude by future perspectives. So quickly, who is ATOS? ATOS is a French multinational company, IT company. It employs about 100,000 people in 71 countries in the world. And one of the three pillars of ATOS is taking a part in tackling climate change, and it is the main topic of this symposium. And ATOS is present almost everywhere in France. As we can see, it has 10 delivery centers, 4 data centers, 3 R&D centers, and 10 InnoLabs. InnoLabs, it means the laboratory of innovation. And we are located in Montpellier, the south of France. And my teams, they're called Data-Driven Intelligence Department. We are about 3 data experts with different technical expertise, and we participate in many R&D projects. And of course, we have a lot of customers. So the innovation in ATOS Montpellier focus mainly in the 2 directions. So artificial intelligence for health, like genetics and health pathways. And the second topic is artificial intelligence for environment, like climate risk management, water resource monitoring, and decision support in agriculture, which is the main topic of my presentation. So, the first project I choose today is called Terra Occitania. It tries to use digital soil mapping and enhancing the value of water resources for the goal to suggest crops according to the soil available water capacity. And the second project is called DIVA. Its main goals, it aims to reduce the chemical products in the vineyard, and also to reduce the intervention of mechanical tractors. So by introducing or implementing a deep learning model, which is able to identify and localize of harmful weeds that impact negatively on the growth of the plant. We will see more details in next slides. So let's start by Terra Occitania. Terra Occitania project is a collaborative project with LISA laboratory of INRAE, which are pedologists BRL Group, which are the data owners, and OpenAG. So Terra Occitania projects aims to process the old soil data to produce more accurate soil maps. And we, for the first use case we choose, it's the soil available water capacity to optimize the irrigation in vineyards. So the proposed pipeline starts with scanning the old soil data. After that, artificial intelligence model for text recognition is applied. And the third step is to clean the data extracted and store them into the DONSOL database. And the last step is to apply an extrapolation of this data to predict with the artificial intelligence model the value of the available water capacity of each point of the region. And then the results are displayed into interactive maps. Here I'm showing you just a view of the processed data. Into this project, we dealt with, we identified 4 different formats of documents, and we were able to deal with about 9,200 documents. So for the training step of the text recognition model, it starts by an automatic submission of soil documents, and then we need to define an empty layout for each format identified, and then making a labelization. So we need to enter manually about 20 documents by format, and then the training step can start. After training step, we obtain this kind of table of metrics, and here we need to make a choice or a compromise between the automation and the accuracy rate. In our case, we choose the accuracy of 99.5%, which means that we have about 87.6% of automation rate. That means that the system will ask us to manually transcribe about 36 files by document. That to ensure the accuracy of 99.5%. So after the data cleaning and extrapolation of data, predictive artificial intelligence model are applied to predict the available water capacity at each point. And finally, the results are displayed into soil maps card. As we can see here on the left side, the results obtained in Lat, which is the south of Montpellier, and on the right side we can see the result obtained in the east part of the Hérault department. So now let's talk about DIVA project. So as I said, the goal of this project is to reduce the chemical project in vineyard, like glyphosate, and also it aims to reduce the mechanical intervention because it is more and more expensive. And here I just to point that weeds have a dynamical interaction with the vines. This could have a positive or a negative impact for the plant. And the solution usually involved around automation of treatment, like robotics, but without necessarily providing recommendation. But here, sometimes, no action is better. The goal of the DIVA project is to implement an intelligent tool which is able to make a recommendation to take the better action. So it starts by take pictures from the entire row. After that, we was able to detect and identify the flora. And the last step is to make suggestion for vineyard. As you can see here, some example of images. And the model is able to detect and classify 5 classes of flora. The difficulties encountered in this project is related to the quality of the images. As we can see in the left side, a lot of images are taken in motions, which is a poor, very poor quality. And the right side, a lot of images, we can see the shadows in the middle of the image, which is very complex to deal with this kind of image. Oops. Another complexity in the project is labeling data. If you know, you cannot expect to find an expert to label the image for us. So it's a tricky aspect. And in our case, external data were used to auto-label content of generic weeds boxes. Here are some metrics of data. So we were able to collect about 1,000 pictures, labeled into 5 different classes of weeds by using a Label Studio, which is an open source tool. And we implemented 2 different models. The first model is to detect weeds, and the second model to just classify the weeds detected into the 5 classes. Here we can see some metrics obtained in the classes, and let me just point that here we can see 6 classes because we created a new class to put the not identified weeds. As we can see here, some example that works. So we can see that the model can accurately identify different classes of flora and rows of vines. Also in this image, it's detected accurately almost all weeds present in the pictures. But the model is not very accurate on all the pictures we have. As we can see here, there is a lot of misses. So this example must be improved. So as conclusion, in this project, we encountered several difficulties because of image quality, for the shadows in the image, and also for labeling data. The first results are encouraging, but some classes need more data examples. As future works, we will take more pictures of certain weeds and retrain our model. And also, we plan to deploy the model on mobile or on edge in order to deploy our model. let me just point here that DIVA project received funding from the European Union, and it is a collaborative project with IFV, which is l'Institut Français de la Vigne et du Vin. So, as a future perspective, we plan to work on this directions like flood forecasting and management, water management, remote sensing in agriculture, and maybe disease detection in plots. And we are open to make collaboration with university and laboratories. Thank you for your attention.
Thank you, Dr. Chemchem. There are any questions in the audience? Not yet. Okay, just one question, because, okay, you told about the possibility of doing projects with you. For example, at which scale do you usually prefer to work? Like, let's say, a development partner, or something more like a fundamental research partner? Which kind of preference ATOS and your team has?
Not preference. We are open to make collaboration, so it's not a problem for us.
Okay.
Thank you for your presentation. I was very interested by the first project about the automatic soil mapping applications. My question is, do you have data for other regions in the world, or is it possible to assess automatically also the quality of the soil using maybe other kind of data, maybe satellite data or other cross-referencing, so that you can expand a little bit the databases of soil type?
So for now, we have only on the region of the south of France. BRL Group is work on only Bouches-du-Rhône department, and we are in contact with SCP Canal de Provence, which is another department, and it seems the same type of data. So we can deal with this data. But in other region in the world, maybe later, but for now, not. I have no idea.
Okay, no more questions. So, thank you very much. So,
thank you.
we'll close it.